One second. Yeah, good afternoon to everyone. Now we'll start the 13th webinar. I request Mr. Danu Patel to give the welcome speech to our speaker. Over to Mr. Danu Patel.
Good morning, everybody. We've been saying morning for quite some time, so those who have just come in, it's once again good morning to all of you. It's a very special morning, if you ask me, because we have a celebrity among us as a speaker. And it's thanks to Roma that we can bring him here, and then we can bring such people from all over the world to your desk. This was unthought of 1 year ago. 2 years ago, 3 years ago, there was no other way but to go abroad, attend, pay a lot of money, attend a seminar, meet people like Ronny, Ervik, have some exchange, networking, meet people like Gary. Today, all this has come to your doorstep. So I think we should be really grateful for wonderful organizations that make this happen. Ronny Ervik is a very special purpose, the man, purpose with a man, man with a purpose. Sorry about that, Ronny. Okay, he has got 25 years of experience in solid polymers, and 90% of that has been in rotomoulding. He has been a chemical engineer, which is the core of polymers. So from that core, he has developed into, he has come up and developed a lot of products and worked closely with rotational molding producers all over the world. He is mainly in charge of Scandinavia and Europe. So sometimes you find him at the top of Eiffel Tower, and sometimes you find him in Latvia, or sometimes even nowadays in vague corners of Russia. Ronny has been working with ultra polymers since the last 18 years, and his experience is absolutely unbeatable. So what I would like to really say is, the topic that he's taken today is a difficult topic, but is a need of the hour. Wherever we drive a car in the range, wherever we go somewhere, there is flooding, there are issues. And we always say, Sala, government kuch nahi karta hai. Why is the water not being drained properly and that? So infrastructure is what really India needs. And if we can show all of us some excellent products, I think it's a golden opportunity for rotomolders to think of producing them, marketing them, by using, of course, the right polymers for this. Because whatever goes underground and is under pressure needs the correct polymer and the correct design. With this, I would say, Ronny, it's over to you.
Thank you very much, Danu. Yeah, and thank you for inviting me to hold this presentation. It's a very interesting topic, infrastructure. In Norway, where I'm situated, the highest percentage of polymer supply is going into infrastructure, and then especially pipes. And this picture you can see on the front screen is when I was traveling in a city called Ålesund in Norway. Then there were big operation going on, and they have to dig out the streets to fix infrastructure system. And the infrastructure systems, they are building up over years. So here you can see a mixture of concrete, polyethylene, PVC, steel, cast iron. So there are many materials going into infrastructure, and at different times, different types of materials are popular. In Scandinavia today, it's dominated by PVC and polyethylene. All right. So let's go to the next slide. This is the agenda of today. I will start with a small introduction about infrastructure and how we do it in Scandinavia. When you're working with infrastructure, you need to know about pipe. So I will give you a thorough explanation about pipe and standards going into pipe. And I will show you some rotomoulding products, and I will give you my opinion and how you can become success in infrastructure. And then I will sum it up at the end. Hopefully, we will manage this within an hour. So, what is infrastructure? This is a set of fundamental facilities and systems serving a country, city, or other areas, including the services and facilities necessary for its economy to function. This is a paste and copy from Wikipedia, and that sets it all. So by providing rotomolded products into infrastructure, you will help your country to reduce pollution. You will clean the sewage systems, provide life needed water to children and elderly, provide electricity to hospitals, internet to schools, and boosting the economy of your country. So doing rotomoulding in infrastructure is much more than securing you, your family, your workers a secure income. It's securing the entire nation a healthier and safer life. So that is what I define as rotomoulding with purpose. Perhaps rotomoulding with a higher purpose, as it should have been. In infrastructure, it's dominated by pipe extrusion, wire and cable, and rotomoulding. You can also see more injection molding and blow molding coming in, but those are the three main processing types to infrastructure. And these products, as I said, made it possible for countries to distribute water, electricity, energy, sewage, and that is the key elements for a society to survive. So before you enter rotomoulding and infrastructure, to get there you will need to invest a lot and focus on quality and get full control over your process. And these are some key elements that I will discuss in this webinar. I've gathered some facts from Norway. In Norway, the quality of the water we distribute to each household is a fantastic quality. You can drink it with no problems, you will get no illness, nothing. So tap water you can drink safely, even at public places in Norway. 190 liter water are supplied to each person per day. In Norway we are 5 million people, so you have 250 to 300 times as much people in India, but out of this 190 liters, 10 liters goes to food and drinks. The rest is for cleaning washing machines, dishwashers, watering the garden, something like that. And in Norway we have 1,600 public waterworks. So they are pumping the water and distributing the water and make sure that the water is clean before it comes. And it serves 90% of the populations. 90% of this water is coming from lakes and rivers, and 10% from groundwater. We want to use as little groundwater as possible, as the reservoirs over the world are becoming less and less. 42% of the water goes to households, 24% to the industry, 2% to cabins and vacation houses, and as much as 32% is lost So that means that we have a backload of 70 years to renew our infrastructure in Norway. 10 years ago, there was a municipality in Norway that had changed some of the pipes to polyethylene, and what they removed was wood. So it was a hollow wooden pipe that has been there since the early 1900s. When it comes to sewage, we have 2,500 public sewage treatment plants. You are not allowed to build a house without a sewage treatment system. And we plan to build 500 more. We have 350,000 small sewage treatment plants or septic tanks. So if you multiply that with 250, that would be something like close to 100 million small sewage treatment plants and septic tanks in India. If you have a linear extrapolation. And most of them are made of rotomolded polyethylene or glass fiber reinforced tanks. The system is built up like this, that you have a lake or a river, and you take water from this lake and the river, you treat it so that it's safe to drink. Then you pump it into a pool. For instance, close to where I live, we have a big mountain, and in that mountain they have a pool where they store water for our municipality. Then it's pumped further to each household. Out of the households, you have grey water and you have sewage water. So the sewage is then pumped as much as possible with only due to gravity. It's going to the sewage treatment plant, but sometimes you need to pump it as well. And you have also then water from the streets that needs to go out of the streets, and that is also then by gravity and pumps transported back to the cleaning station. From the cleaning station, all the water is going then back into the rivers and the lakes or the ocean, and all that is solid is going then to be deponized, and then it can be used as fertilizers. So it's impossible to talk about infrastructure without knowing about pipes. So I will go through about pipes, tell you about pipes, and the importance that you know the importance of pipes in infrastructure, and that you know some of the legislations and standards that are used in pipe. In Europe, pipe is the third biggest segment, and it's sold a lot of material in pipes. It's more than 2 million tons going into pipes. And the material used is dominated by polyethylene and PVC. And out of all these pipes used, materials used in pipes, 70% is going to building and infrastructure. So the pipe guys are really focusing on infrastructure. So the pipes sector, it's you can say it's two different types of sectors. At least those two I will focus on today. It's gravity pipes, where you use gravity to distribute or to move sewage in the pipes. That is the most inexpensive way to transport the sewage and also water from the streets. And this market is dominated by PVC. 60% is it's PVC, mainly due to high stiffness and cost. The other one is, sorry. The other one is pressure pipes. And pressure pipes, that is water and gas distribution. To distribute water, so tap water, so that when you open the crane in your kitchen and water comes out, you need to have pressure. And this is dominated by polyethylene. In Scandinavia, we only use PE 100. No one is using PE 80 anymore. I will tell you a little bit about PE 80 and PE 100 is. And the trend is going towards PE 100 RC. So RC stands for resisting cracks, crack resistant polyethylene 100. And especially in Germany and Scandinavia, it's PE 100 that is dominating. So some of the standards used is and that we have to learn if we are entering infrastructure and you're dealing with pipes are ISO 12162, ISO 9080, and ISO 1167. So I will go through these tests and some others now. Since pipe is a very easy design, it's round, then hoop stress is the most common test in pipe. So you have a pressure inside the pipe and you have a pressure outside the pipe. The pressure inside the pipe is, for instance, gas or water, and outside you have the soil, and if it's in a street, you have the trucks driving over it, and so on. And then you have a calculation that you can see on the left side, or at the right side. That's an alternative equation. And when you know the pressure inside, you know the pressure outside, and you know the diameter of the pipe and the thickness of the pipe, then you can calculate the lifetime of the pipe. And schematic, you get a schematic creep curve for the pipe. So what you want also in pipe, as in rotomoulding, you want to have ductile failure. So you measure the time and you do tests, and if you have a failure at the first part, and then the failure is ductile, then the failure is normally caused by a mistake during processing. If you have a brittle failure between the mechanical knee and the chemical knee, then it could be that the pipe is processed wrong, or you can have used up all the additives, or it could be a combination of failures. If you have a failure after the chemical knee, then it's mainly due to you have no more additives left. The material has a stretch crack or something like that. So that, by doing this hoop stress test, creep rupture test, then you get valuable information how good is the material you put into a pipe. And then you can extrapolate how many years can you say that the pipe will survive when it's buried down under the streets? So you can use ISO 9080 to do this extrapolation. And normally what you want to do is you want to test it with high temperatures, normally 80 degrees and 65 degrees, because then this test doesn't take years to perform. And then you can extrapolate it to 20 degrees, which is the standard. In Scandinavia, when it's going under the ground for 1 meter or 2 meters down, then you know that it's never ever going to be 20 degrees at that area. And by doing this, you see how long do you have a ductile failure. Then you can classify your material into P80, P100, and P120. So what 25, which is the new standard coming up. So if you go into 50 years lifetime, it here, and then you see what megapascal is your when you have this brittle failure. You go 50 years into the curve, you should only have ductile failures here. And then for P80, you are at 8 megapascals or above. P100, you are at 10 megapascals or above. And P125, you are at 12.5 megapascals or above at the 50-year lifetime. So all pipes used in infrastructure in Norway should have a lifetime at least 50 years. They want to have it a lifetime of 100 years. And this is also very important for you to know that are doing rotomoulding and are entering infrastructure, because these times, what is valid for pipe will be valid for rotomoulding. So in rotomoulding, you should not serve a product into infrastructure that is at least not guaranteed for 25 years underground without any failures, because it's so expensive to stop the traffic, dig out the streets, replace the part, close it again, and then open it again. So that operation is so costly, so that you have to make sure that your products can survive 25 years in this environment. And I'm sure that in soon they want to have a guarantee for 50 years. For the ISO 12162, you can see here is you have the minimum required strength. This is what we have what we talked about at the hoop curves. So if you have 8, you have a classification number of 80. That's it. That means that you get a PE80. But when you design your product, you use 6.3. So that is only the minimum required strength divided by 1.25. And the same if you have a P100, you design the product with a stress of 8. In Norway now, they want to go to P100 plus. That means that it's more than P100. It's P125. And they focus on creep rupture strengths. And they say here 12 megapascals. And they want to have this. They want to have this RC grade, this slow crack growth. And you have to pass 500 hours at this test, and you have to have a resistance to crack propagation at 0 degrees, tested at about 10 bars. So this is coming, and this is stuff that the pipe guys knows about, and you have to work with the pipe guys, and they are often referring to these tests. And if you don't know this their language, you're lost in a way. So you need to learn the pipe language to work in infrastructure. Another term they are referring often to is SDR. That is standard dimensional ratio. And that refers to the diameter of the pipe divided by the wall thickness of the pipe. So if you look here, common SDR is I have a pipe of SDR 32.5 or 17 or 11 or 9 and 7.3. So what is important to know is that a higher SDR, for instance, SDR 26, indicates that the pipe has a thinner wall than a pipe with a SDR of 11. That is some of the few standards in pipes. There are many more. So it depends on which kind of product you are entering. If you are entering the gas distribution, if you want to enter non-pressure drainage, or if you want to have tap water, or if you want to have fittings, then you need to know these standards, at least in Europe. Another language or a term they use is MAOP, or often also called MOP. That is EN 12201. EN, that stands for European norm. And then you have the minimum required strength. And then here comes the difference SDR types in. And the MAOP is a maximum allowable operating pressure in bars. So if you have a thin-walled pipe, a PE 100, then you can have 6 bars. If you have a thicker walled pipe, same material, same dimension, you can have 25 bars. So when you have a pipe, it's very easy to calculate. It's not that easy with rotational molding. So when you enter a pipe website, a website for a manufacturer of pipes, you will often see these kinds of schemes. So here you have the wall thickness and the diameter of the pipes. You have different types of materials. You have PE 40, PE 80, PE 100. And it's very easy for those guys that is buying pipe to go in and see what they need. From the materials of the pipe, there's a lot of specifications. You need specification on the compound, on the color, on the carbon black, on the dispersion of the carbon black. Is it allowed to rework the material? Yes, in some cases, but then only from the same compound. You cannot go out and buy regrinded material and put it back into the pipe. There is a limitation on the MFR. You need to have a certain OIT. You need to measure the slow crack growth, the resistance to rapid crack propagation. Will it affect the water quality? And of course, you need a hoop stress analysis. And here are some different types of materials, which I often show. I will show it later also in this presentation, but it gives a good example that buying a black material, when you process it, you get a black pipe or a black rotomoulded product, but it's necessarily not good. what you want when you look at it in a microscope, you want to have an even distribution of the carbon black. And there are two ways that the carbon black or the carbon black master batch can ruin the material. So if you look at this picture at the upper right, the master batch and the carbon black is actually very good, but the extruder they are extruding it on is poor. If you look at the lower left, the extruder is working very well. So it's distributing the master batch very, very well. But the carbon black master batch you are using is not good. You have a too big variation in the size of the carbon black in the master batch. And the final picture, lower right, is that when the carbon black master batch and the extruder is poor. So this is impossible to see if you don't do microscopy analysis on it. So, but there is not only polyethylene used in pipes. There is also polypropylene. And in polypropylene, you have three different types of polypropylene. You have a homopolymer. So if you look at the drawing here, all red, that means that it's only polypropylene. All the red dots are polypropylene. And it's normally used in Scandinavia, at least, it's used inside the buildings. Because homopolymer of polypropylene has a very low impact strength. In Norway, we can have areas where in the winter is -30 degrees, and if you are installing something underground at -30 and using a homopolymer, it will crack, definitely. Then you have a random polypropylene, where this polyethylene chains, the blue one, they are put in randomly. And this is used for hot and cold water. And the last one is heterophasic block copolymer, or just call it block copolymer, where you have blocks of polyethylene in the polypropylene chain. This is used for drainage, sewage, soil and wastewater, cable, pipe protection, industrial pressure piping systems. So it's only let's say those that are installing the pipes, they can choose if they want to use polypropylene or polyethylene, and if it's hot water, then normally they go with polypropylene. But we also have polybutylene, and polybutylene is a very, let's say, new family to the polyolefins. But it has some interesting characteristics that is appreciated in the pipe industry. So if you look at some of the applications that is used in pipe, we can look at hot and cold water pipe, sewage pipe, gas pipes, steel pipe coating, industrial, rotational molding, jointing technique. I will take out the rotational molding on this, and we'll go deeper into rotational molding later in this webinar. For hot and cold water pipes in Scandinavia, it used all to be brass, but now it's changing to more and more polyolefins. So you use polyethylene and polypropylene in pressure pipes. Normally random in polypropylene, random in radiator connections. Polypropylene or cross-linked polyethylene or polybutylene in floor heating and wall heating. That's you have to notice that you cannot use homopolymer in this application. And for cooling water, we use often, or cold water, we use polypropylene, cross-linked polyethylene, and polybutylene. In Norway, if you are installing pipes in houses, you need to have a double system. If you look at this picture, you have a hex. This is a cross-linked polyethylene on the inside, which is supplying the water. And then we have on the outside, we have a polyethylene pipe. So that if you have any leakages, it will not leak in the wall of the house. It will leak in from this PEX pipe into the polyethylene pipe, and then it's going to a central point where you have drainage. And then you can see that, okay, now I have a leakage on the pipe number 4. And then you can close this pipe and replace it. And then you will not have any water damage in your house. So also a bit short about crosslink. Why did I use crosslink material? It's improved heat deformation resistance. It has improved stress crack resistance and improved pressure resistance at very high temperature, improved creep resistance, and improved impact resistance. What you should know about cross-linked material, polyethylene cross-linked material, is that it's not recyclable, mechanical recyclable. It might be that we can chemical recycle it in the future, but that's a bit way ahead, but hopefully we can manage that. So how do you get a cross-linked pipe? Well, you do take a normal polyethylene, and then what is most common is to use so you use peroxides in the extruder to cross-link it, or you can use silane. Then you need to wait a bit before the cross-linking takes place, because silane needs water, and the water that it takes from the air normally, from the humidity in the air. Or then you can radiate it. So the different types are, if you have a PEX A, that's peroxide. If you have a PEX B, that's silane. PEX C is radiation. Someone called the ATO technique PEX C and the radiation PEX B. But that's just a comment, small comment. So for underground sewage and drainage, for smaller diameters, well, smaller and smaller, now it's the largest I've seen so far is 1200 millimeter. Polypropylene block copolymer is increasing. Still dominating by polyethylene, but polypropylene block copolymer is increasing. PVC is very often used, but for larger diameters, P100, P100RC, and P100 XL. So P100 is then you have this hoop stress 10 megapascal, still 10 megapascal, but you have a stress resistant material. XL is if you make a 2.5 meter diameter continuous extruded material, by using a PE80 or normal PE100, you can have some sagging on the top, because the weight of the material when it's hot will move and make it oval. So therefore they have developed this XL grade, which has low sagging material. For gas distribution, it's mainly P100. Or yeah, it's leak-free, good record even during earthquakes, no corrosion, lightweight, flexible, and high toughness. So in UK, it's a big distribution network of gas pipes. In Scandinavia, you can hardly see it. In Scandinavia, we use mainly electricity for heating. A big industry in Norway is steel pipe coating. We have a steel pipe, and then you coat it with polyethylene. The reason for that is that polyethylene has fantastic corrosion resistance. So when you pump oil or gas from the North Sea to land, then they use steel pipe, but due to the corrosion, they have to coat it with polyethylene. The steel pipe has fantastic mechanical properties, but it's even better now when they coat it with polyethylene. So it's good chemical resistance outside the PP pipe, sorry, and UV radiation during storage. Another one, which is have some examples that is also increasing, especially in Norway, it's the fish farms. We have for salmon fish farming, we have a lot of these installation that you can see upper left here, and they are all over the coast. They in this installation they can use PE80, no problem with that. But since the pipe producers are already using PE100, there's also a lot of PE100 being used in the fish farms. We have culverts for leading water, big diameter pipes. We are installing a retention basin, which is also, here is an example of a spin welded pipe that are, no, sorry, it's spin pipes and it's welded at the end. That can store enormous amount of water. Because when it's in Scandinavia, we get more and more water per time, like not like the monsoons that you have, but when it rains a lot. And the pipes that we have for taking out the water in the streets are too small. Therefore, we need to have a kind of retention basin to store the water so that we can fill, so the pipes that we have are not overloaded. And a lot of chemical tanks are also used by welding techniques and pipes. So you have a pipe and a sheet, and then you weld it together, and then you make a tank. If you need a one-off tank, that is much more inexpensive than doing it by rotomoulding. Some about the jointing techniques. In pipes, they use gaskets, they use shrink fit, push fit, press fit, and welding. So if you look at this upper right, you have a gasket inside the pipe, and then you just push the next pipe into it, and then it's leak-free. Here you have a press shrink fit, so that you push the pipes into a connector, and then you have a device here that you screw on, so that you shrink the pipe onto the device that is made of copper. And then you have a press fit and push fit and welding. And I will go a bit deeper into welding, because welding is also important to know about. You need, if you're going into infrastructure, you need to have a welding department. So only thermoplastics are weldable, but they are also only weldable with similar materials. It is possible to weld a pipe onto polyethylene, but it's not possible to weld a polypropylene pipe onto a polyethylene rotomoulded product. And it's very strict when you are welding pipes. You need to control the dimension, method, time, pressure, temperature, and that has to be logged. And if the municipality wants to know about this, the log, you are obliged to give it to them. So the most common welding techniques are for HDPE. It is butt welding. I will show you this later on. Electrofusion welding, extrusion welding, or hot air welding. It's very typical used in polyethylene. Same with PP, but not so much for electrofusion. For PVC, it's not that easy. but you can use infrared welding. And for polybutene, again, it's butt welding, socket welding, and electrofusion welding. And the different types of welding you can see here. So if you're doing butt welding, then you have a pipe fixed, both ends are fixed. You have a mechanical device that takes these two pipes apart. Then you have what we call a mirror here, which is heated up. This mirror is heated up to, yeah, I'm not sure, but around 200 degrees. Placed between those two pipes, and the device is then pushing it together with a certain pressure, holding it there for a certain time, open it again, remove the mirror, and moving the two pipes together and pressuring it together with for a certain time with a certain pressure, and then it's welded. And by doing it in this controlled way, you have a weld that is in mechanical strength as good as, or 99% as good as, pure extrusion, if you have done it correctly. Here you can see socket welding. So there on one side you have a pipe going in, so you're heating the outside. On the other side you're heating the inside, and then you're pushing it into each other. So the outside of one pipe is then welded onto the inside of the other pipe. On this one you have infrared welding techniques. Here you're using a kind of a cap that you are placing above two pipes. You have then setting, there are some wires inside this cap, and then you put the electricity on, and it melts the pipe and the cap itself, so they fuse together. Here we have an extruder welding that is pushing polyethylene through the extruder, heating them up, and then they're pushing it along the place you want to weld. And this is the same, but instead of extruder, you're only using hot air, and you're manually feeding the welding rod. So if you're going into infrastructure as a rotomolder, this extruder is a necessity. This you need. You need to have skilled people doing it, and you need to be able to weld high density polyethylene, which are used in pipe, with a much lower medium density polyethylene, which are used in rotomolding. And that is not so easy, because the polyethylene pipe material are much stronger than the polyethylene we are using in rotomolding. The MFR is much lower. So you cannot use the parameters that are set by pipe in rotomolding. So there you need to find out what kind of parameters are working. And it's a lot of testing to see if your welds are good enough. All right, this was about pipe. As you know, it's a lot of things going also on pipe. We need to be able to know what is happening in pipe to supply rotomolded products into infrastructure. And I would encourage you, if you are going into infrastructure products, that you make an alliance or a partnership with a pipe producer, so that when the pipe producer is selling a pipe, he could also sell a manhole or a pump station or something like that from you as a rotomolder. And then you both will learn a lot from each other. So if you go back to rotomolding, in polyethylene is dominating in rotomolding, as you know. According to Polymers, it's more than 85% in the world that are using polyethylene. There are still some PVC production, but not so much. He says that the global volume is 1,800 kiloton, but I think we can double or triple that number at least. In Europe, it's approximately 275 kilotons going into rotomoulding, and it's mainly polyethylene. The polyethylene number in Europe is probably more like 95. If you look at it in Scandinavia for rotomoulding, 40% of what we produce is for infrastructure. So every pipe manufacturer in Scandinavia, like the big ones like Uponor, Pipelife, Wavin, all of them, they have their own rotomoulding department. And that is often not enough. So they have partnerships with selected rotomolders to produce some of the products for them. And the smaller pipe producers, they have a partnership with the rotomolder to make the rotomolding products for them, so they can focus on pipe, and then their selected partner are focusing on rotomolding. So this is how it works in Scandinavia, and we are highly focused on infrastructure. So if you go into some of the products that are used in infrastructure for rotomoulding, it is, I would say, manholes and inspection chambers. And for these products, we have to oblige to a standard called EN 13598. And you have two versions. You have version 1, which is for shallow inspection chambers, and version 2, that is for manholes and inspection chambers in traffic areas, or if they are deep underground installations. If they go down 3 meters, you have to go with 2. If they go down 1 meter onto the ground, or 1.5 meter, you have to follow the number 1. And so it's I call it sewage flow directors. That is what we normally call as manholes. But it's not only manholes as a sewage flow director that have to follow these standards. It's also pump station, inspection chambers, drinking water manifolds, rainwater collection systems, and cable ducts. And in this test, you have to have a structural integrity. That is normally a vacuum test, because if you have a pump station or a manhole, you don't want the bottom of the tank to bulge. You want to keep it stable. Then you have a impact resistant test. That is, you need to have that, because when you're putting it on the ground and you're backfilling it, it should not crack. Or if you're moving away the lid and you're just going to inspect it, and you lose your hammer or your flashlight or anything like that into it, it should not crack. You have to measure the ring stiffness, because it's underground. You have a constant pressure of soil around it that is pressing the tank. So you have to have a minimum ring stiffness. It's also in Scandinavia, we have high water beds. We have water beds going all the way up, covering the whole tank in some areas. And that is also adding pressure. So you need a certain minimum ring stiffness. We have often ladders in these tanks, so that for entering an inspection, so the ladders have to be secure and safe to use. And of course, it needs to be watertight. And if it's in a trafficked area and a truck drives over it, it should not collapse. So you need a load bearing capacity. So all these are covered in the EN 13598, and you have to pass it. So it's quite tough test regime to get an approved manhole in rotomoulding. And here are some of the manholes. So normally it's 3 different products. You have a base like this. So here, for instance, you have 3 pipes coming in, and then the rotomolded product is joining those 3 streams coming in and 1 stream going out. Or you can just have 1 stream going through, and then this is only for inspection. Or you can have 2 coming in, or you can have 5 coming in and 1 out. So there's a lot of different opportunities in rotomolding. So you need to have many molds. So you can what you can do is that you can have this as 1 mold, and then if you want to rotomold the whole manhole as 1, you can just shift the base of the mold. Or you can mold this alone and then assemble it together either by welding or by using gaskets and clips, so that you can have many molds on the warehouse, and then just clips it on the right on the middle section here, and clip it on the riser. The tendency in manholes is that it's going to be bigger and bigger and bigger in diameter. Especially for those that you are going to enter. So in Scandinavia, you have to have a 1,000 millimeter or 1 meter diameter. I like to say that is because the persons that enter is getting fatter and fatter, but that is not true. It's something about safety and health. So it's getting bigger and bigger. For manholes, there is an expert which has also been in India many times. His name is Mickey Burmil. He has run factories producing manholes for a lifetime, I would say. He's now a consultant, and you can contact him in mickeyburmil.com. He does all the engineering, he does the design, and he assists you to making manholes that will last for a long time. And he has done a calculation saying that rotomoulding is very efficient when producing manholes if you assemble them afterwards. So that means that if you produce the base, the midsection, and the riser by itself, and then later on weld it or clip it together, then he says that you can produce 1 product in just over 3 minutes. So how he has calculated that is that if you have, let's say, a nominal wall thickness of 10 to 12 millimeters, average weight of the product is 25 kilograms. Average oven is 25 minutes oven time, and then you have 8 products on the spider. So you have 4 products on each side of a straight arm. So then he calculates the production time in 1 hour. So he consumes 650 kilogram per hour. 3 shifts, 9.6 tons, 1 month, 20 days, 192 tons. And then he managed to get this calculation, 3.125 minutes per product. So if you compare rotomoulding with, for instance, injection molding, which is also entering this area, rotomoulding is quite efficient. All right, that was manhole. This is pump stations. Also very useful or needed in infrastructure, because you need to pump in some areas. You cannot only rely on gravity. If you are in a hilly area, you have to pump the sewage from sea level up to perhaps 50 meters, and then gravity down to sea level again, and up 50 meters. Yeah, you know what I mean. And in this pump station, normally you have different types of sensors saying that, okay, now the tank is empty. Now you can shut off the pump. Now it's 20% filled. Okay, perhaps we should start to pump on a low energy. And then when it's 50% filled, okay, now you go on higher energy on the pump. and when it's full, you go on full speed on the pump. But what is also worth to mention is that there are several different types of pumps. You have at least in India, I don't know, but I would guess you have at least 50 to 100 different suppliers of pumps, and all of them are fastened differently. There is no uniform way to fasten the pump into the tank. So you need to have a kind of a flexible system. Either you join one of these pump suppliers and say that, okay, I will make the tanks for your pumps. Or if you want to serve them all, you have to have a kind of a universal fastening device that can fit all pumps. And you need to have several outlets and inlets, because you never know where the pipe is coming in or coming out. And you need to know how can I securely fasten the pipes into the pump station, because in all of these applications you don't want to have any leakages of sewage into the ground. If you have any leakages, you have to dig a hole, get it out, fix it, place it back into it, and it's very costly. And it's normally the rotomolder or the entrepreneur that has to cover these costs. Another one is drinking water applications. This is a company I used to assist in the past. They were making distribution chambers for drinking water, so that when the water came in, they could, in this system, they could supply 6 households, and then they had the 6 on the other side. So in total, they could supply 10 households per chamber. And then you can see that with this system, they have also a pipe in a pipe system. So you have one pipe going into the house, covered by another pipe. So if you had a leakage, the leakage will come back to this tank. And then you can see which of these pipes were leaking. You could also install a water meter here, so you can see how much water each household were consuming. And in Norway, that is free. You don't have to pay for, if you use 1 liter or you use 1 billion liter, you pay the same. You only pay for distribution, you don't pay for the amount. But in the future, water will be a rare resource and you have to pay for what you use. So then easily by installing a water meter here, which are then by reporting back to the municipality how much Gary Latigan is using, for instance, and then the municipality will invoice him by usage. This was also then going into a trafficked area. So here you can see that the 10 tons were applied to the top of the tank, and it passed. 10 ton, no collapse, no. You have only a certain deformation which is allowed, and 10 tons that is coming from if you have a 40-ton truck, and then they say, okay, this 40-ton truck has 4 wheels, so let's say it's 10 tons per wheel. The later version they have made now is that they have a freestanding top base, and this base is a very special design and foamed, and then they pack gravel underneath here, so all the load from the top is only coming into the base, to the top section, and the base can and this can flex a little bit, but the load is not transferred to the base section. That means that the base section can be produced in a thinner wall thickness, and they can save a lot of money on material and cycle time by doing it like this. Here you can see that they have still these six pipes for distributing water to household, but they have also included an optional fire water pipe. So if it's a fire somewhere, you can go down, you can connect the fire hose to this pipe to take out the fire. So it's a very intelligent manhole. And you can also see that they wanted to make it blue, to indicate that it's blue on the outside means that it's drinking water. On the black pipes, if you have a blue stripe on the black pipes, that means that it's intended for drinking water. If you have a brown stripe, it's sewage. If you have a yellow stripe, it's gas. So when you dig up the ground and you see a black pipe with a yellow stripe, then you have to be careful, because it's gas. And they wanted to make it white on the inside, because when you enter it, the tank itself tries to take away all the light. So it's very difficult, even with a flashlight, to get good light in it. But by making it natural on the inside, the tank doesn't steal that much light. So it's a very clever and interesting way of making a manhole. Rainwater, the distribution chambers. You can see under the streets in all over the world, you need to get rid of the rainwater, and that's normally going into a tank, which are then distributing it into a pipe. In Norway, as I said, we have got more and more of this rain per time, and that means that all our pipes for rainwater are actually too small. So we need to install also some retention basins. But this is also very similar to a normal manhole, but just with a different base. And then you have all kind of different cable ducts. I think that in Norway we still have most of the electricity in the air, but there is an ongoing discussion to remove it from the air to the ground. And all internet cables, TV cables, all that kind of stuff are going into the ground. And I'm sure that that will also be a trend all over the world to get all the electricity from air to ground. And then you need cable ducts. And the most important thing with cable ducts is to keep it watertight. And that is not a problem with rotomoulding. So rotomoulding, cable ducts, perfect match. All right, that was manholes and inspection chambers. Some other products, it's septic tanks. For septic tanks, it's EN 12566/1. That's the norm that we have to fulfill to be able to get a CE marking and be allowed to sell it in Europe. And the most important criteria for septic tanks is I mentioned here. So you have to measure the overall dimensions, accessibility, water tightness, volume, structural behavior, and hydraulic efficiency. The hydraulic efficiency has actually not so much to do with the polyethylene itself. It's how fast can you separate water and feces. So here you have in this tank, it's 3 chambers. So sewage is coming in, and then through a hole it's going then to the next one, and then you have a lot of solids in this chamber. water is going in here with some solid, and then next one is going into the third chamber, which is purely or mostly liquid. And then this is either then pumped into another tank that is creating it even further, the liquid, or it's being pumped into a tank which is taking it to a big sewage treatment plant. Then you have the sewage treatment plants. That is also 2566, but it's number 3. And additional to all these tests that you have to do in septic tank, which you also have to do with the sewage treatment plants, you have to secure the efficiency of the treatment. So, for instance, you have to remove more than 90% of the phosphoric phosphoric compounds in there, or and also BOD 90% have to be removed, and that's a special tank. And then, if that is okay, then you can take it into the ground, or into the river, or into the sea. Then it's so pure that it's allowed to put it back to the nature. In addition to also, this is a schematic test of how the pit test is done, and the pit test is very well known in Europe for all that is going into the infrastructure. So you have a chamber, you are placing the tank in the chamber, and you're filling it with a certain type of gravel. It's specified very in detail how you should fill it, and then you should also then fill it with water, and you need to measure any bulging either way, full with water. And it should stand like this, full with water for 24 hours, and then you should remove the water, and then you should see if it's collapsed or anything like that. So it's very strict regime how to make or approve a septic tank and a sewage treatment plant. And I will just show you one of my customers how he's made a film of his sewage treatment plant, and I will show it to you how it works.
Odin miljø. Rent vann, vårt felles ansvar.
Yeah, so he's very successful in making sewage treatment plants. As I told you, 350,000 sold in Norway only, 5 million people. It's a strong competition between the glass fiber reinforced material or tanks and rotomolded tanks, but I think rotomolding has so much more potential of dominating this sector due to the flexibility of the rotomolding process and the welding of a pipe into a tank and make it 100% waterproof compared to glass fiber reinforcement tanks. So there are also a lot of different methods of how to chemically, biologically, mechanically treat the water to improve it. So I think this is a great opportunity for the rotomoulding business in India to look at. Oh yeah, no, sorry, I will not show that again. Next one. Oh, sorry about the text here, but another one also here is oil and grease separators. And for oil and grease separators, as well as for septic tanks, and as well for sewage treatment plants, there is also a material criteria. So you need to have a MFR between around 4, higher than need, 30 density, and you need to check the tensile properties. It's normally stated on the data sheets of your supplier, so it should be no trick to find a material that is suited. But additional, what is very interesting with the oil and grease separators is that some part that is coming in is floating, and another part of the oil and things are floating, are sinking. So you have oil or grease on the top of the fluid, you have water in the middle, and then you normally have grease on the bottom. So how to separate this? Well, the things that go to the bottom, that is very easy to separate, but the thing on the top, they are normally putting in some chemicals that that is reacting with the oil and make it much more dense, so that over time it's also sinking. So you are taking out, or you are taking out something from just you have a pump that is pumping from the top and the bottom. So also a big market in Norway, mostly for industrial purposes. So in Norway, if you are placing a grid in the floor of your garage or your mechanical shop, or if you have a grid in a kitchen or anything, then you have to have an oil and grease separator. You're not allowed to put something in there where you can flush all kind of oils and grease and the things into a duct without having oil and grease separators in Norway. So so industry is a very big market for the industry for oil and grease separators. Yeah, we have discussed water retention bases a lot. This can be pipes, as you see here, but more clever designs are to make these here rotomoldable instead of concrete. So you have a rotomoldable base that is connecting 2 of the pipes, 2 and 2 and 2, or all the pipes, so that makes sure that you have no it's very easy for the water to in all the chambers, and this is very good to place, for instance, under a parking spot. So if you're making a parking spot in the city, so why don't you put a retention basin under it? It's covered, and it will help during heavily rain. Then you have a lot of smaller devices. You have this is a pumping station for cottages. So you just have a small septic tank of 80 to 100 liters, which is then with the same sensors as the big one, but this is then pumping the sewage from your cottage to the main sewage line that is going to the main sewage treatment plants. Very easy to install and very flexible and reliable system. You have fittings. This is a polypropylene fitting, which is 1 meter in diameter, made by Partner Plast to Pipe Life. so that they can connect the big polypropylene pipes to each other. The smaller fittings are normally in Scandinavia injection molded. Up to 300-400 millimeter in diameter is normally injection molded, and it's the size are increasing by injection molding. But it used to be in the past all rotomoulding. But for the bigger dimensions, rotomoulding is much more efficient than injection molding, and cost efficient than injection molding. So some pictures from Mickey Burmill. He has a lot of different examples how you can use different types of sections to make big manholes, small manholes. Here is some of the storage area that you have. So if the contractor says that, okay, I need one that is 4 meter, I need one in 2 meter, I need 3 in 1 meter, then you have all the flexibility in the world to just play with almost like Lego and give the customer what he needs. You can also bring all these parts to the construction area and weld it or connect it on site. So it's very flexible also from a logistics point of view. Some other examples is the drainage tank. Here is a speed reducer tank. So if you are moving sewage from a hill downward to reduce the speeds, you can of the flow, you can install these manholes in the hillside. So it's a lot of different examples, and here is very good examples why you need a welding department in your rotomoulding site, because there are many one-offs. That means that here we have a problem. We need a tank or a manhole that looks like this. We have 3 pipes coming in at 1 meter height and one coming in at 1.5 meter height, and it's all going out at 2 meter height. So please, can you supply this? And then you can say yes, because if you have a welding department, you can take a standard rotomoulding manhole, cut and weld it in, and then sell it as it is. And yeah, you can put the rotomoulding part directly on a pipe like this. So you have all the possibilities in the world when you are working with pipe and rotomoulding, and you have your own welding department to supply the customer exactly what he needs. All right, so now I'm starting to finalize. So how can you be a success in infrastructure? Well, it needs a lot of focus, attention, and support from the government. But the government will not move until you have a plastic organization that is really active and then pushing for standardization, for allowing polyethylene or plastics to be used. You need to convince the region and the municipalities to move away from steel or concrete or what they're using and sell the benefits of polyethylene. You need to guarantee them 50 years or 25 to 50 years lifetime and show the benefits of installing a high quality system, how that will help them save costs. You have to work with the test houses so that the test houses are accredited to perform the tests that you need in rotomoulding. You have to work with the material suppliers to make sure that they are supplying materials that are covering your needs. And you, as a rotomoulder, you need to focus on quality in all your sections, not only on the machine and the molds and the operators. In the entire organization, you need to have a quality department, you need to have a design department, you need to work with the test houses, and you need to make sure that the products you are leaving your factory are really suited to last for 25 years plus. So for the standardizations, ROMA, I think ROMA should be active and one of the drivers for setting the standards. I'm not sure how many standards you have for rotomolded products and infrastructure in India, but you need to have high quality standards, making sure that there are no rotomolders coming in and just selling on price and with low quality. Because if the product fails, the municipality, the government, the regions will say that, oh, we will ban rotomolding because it fails after 2 years. And it's so costly for us to use rotomolded products. So you need to make sure that the only people allowed into this sector are high quality rotomolders with a quality-minded mindset. And you should involve pipe manufacturers in this to make the standards, because they are used to standards, and by working together with the pipe manufacturer, they get confidence in that you are doing the right thing, and that they can easily recommend to their to their customers that with a plastic pipe you should have a plastic manhole or a plastic pump chamber or plastic sewage treatment plants or whatever. And you should also implement yearly audits by the rotomolders and reapproval of the material and tanks every 5 years, because in Europe we have seen the same in the startup. There was a lot of people starting up with rotomolding infrastructure tanks, and then for the test they used a high quality material, and for the production they used the cheapest material they could find. So for materials, I've been working with materials in rotomolding almost 25 years. Started in '96 with Borealis, and I would encourage you to use hexene. Hexene is a tougher material. It's easier to pass the standards than with a butene, and normally the materials are black. There are some making it gray, or you can see the blue or whatever, just to we put the brand on it. It doesn't matter. It needs to be, if you compound in blue or if you compound in gray, if you have the same traps, you can go in the same traps as if you compound in black. And I would say that you need to focus as a material supplier. You need to be better and better and better. I tested a lot of different materials, and to be a bit frank, all the materials I've tested from India will not pass the strict infrastructure testing regime. I think that you need to focus on the homogeneity of the material. I'm now working with a European supplier that is struggling to get the homogeneity of the material 100%. Because if you don't have a homogeneous morphology of the materials, you will have a really bad internal surface. And if you have a bad internal surface, you will have crack. And if you do, and all should do arm impact test on the materials, on a rotomolded samples. I agree that on all other tests, you can do compression molding specimens. But for impact, you should use arm impact on a rotomolded sample. Then you know that it's like you're testing it on a sample. That is what they do in the rotomolding world. And if you have homogeneity problems, you will see it immediately. And you should have no brittle failures when you do arm impact testing. If you have a brittle failure, you have problem with the material. And that is how the material supplier should really focus on arm impact and remove the brittleness from their materials. For the rotomolder, if you're not 100% committed to do it in a high quality manner, to produce the manholes, the pump chambers, the septic tanks in high quality, do something else. Because this requires a great focus from you. You have a huge startup cost. You have to buy 50 molds if you're going into manholes. You need to work with a designer to get the test cost down. You should do finite element analysis so that you don't have to test 3 times before you get an approved tank. You need to work with a test house. You need to obtain a certificate. You need to buy molds. You need to know how to weld. Maybe you need to train welders as well. You have audits and you have quality controls. So don't start with it if you are not 100% committed. But if you do, you can make good money and you can help your country developing a fantastic infrastructure system. So I hope that many of you really go into this sector, and I hope that all of you that goes in are really 100% successful. So maybe in the future, when you are making rotomoulding products, you are having a partnership with a pipe producer or pump producer, and you are implementing high quality control, and you're making the best manholes or septic tanks in the world, then you have opportunities that are endless. And maybe we see in the New York Center a manhole that says made in India. Thank you very much. I'm now open for questions.
Yeah, we'll have the session later on. Yeah.
All right.
Vipul bhai.
Sir, I made you presenter.
Okay. Yeah, good afternoon, dear friends. Thank you very much, Mr. Ronny, for the wonderful presentation and accepting ROMA request for this webinar. You have highlighted the detailed presentation of infrastructure products and their raw materials and various applications. It is a really upcoming market in India for rotomolders, and it is a great opportunity to switch over from our regular products to the infrastructure product and high value infrastructure product. Mr. Ronny has very well explained about the various infrastructure products, starting from the pipe, the testing facilities, raw materials, different new products like underground tanks, sewage systems. Then he has also explained about the rainwater chambers, septic tanks, sewage system, and grease separated tanks. There are the various infrastructure products which are required in India, and it is an upcoming market. And Mr. Ronny has given a very well presentation. It is definitely a very fruitful to our all members and other people. I thank Mr. Dhanu Patel of Reinhardt to welcome our webinar speaker, guest Mr. Ronny. We also welcome you to our ROMA family and anticipate your active participation for ROMA growth and upgrading rotomoulding industry in India. As you know, ROMA is doing a lot of activities and regular conducting webinars and seminars. We are always trying to cover topics related to the raw material processes, the design, molds, machine, testings, and government standards, soft law management. We work towards the Indian rotomoulding industry upgradation with the par with the international international speaker who are leader in their subject and field to give the technology to our members. We have just completed 1 year journey and from this industry, and we got from the industry we got a very good response from the industrial leaders and manufacturers and suppliers. ROMA itself has a well-established name worldwide, and now we become the third largest Rotomoulding association in the world. We have almost crossed 97 members, and in coming year, in the coming time, this year we are target more than 200 plus members in this year. So we are targeting that we will become the second largest or the first largest rotomoulding association in the world in the coming years. Now I would like to welcome the new members which are made during this month. First of all, I would like to introduce as a molder member, Metro Industries. Metro Industries, it is from the Ichalkaranji. They are the manufacturers of the molding tanks. I welcome Mr. Sumit Chen from the Metro Industry. Is he present in the webinar? Mr. Sumit Chen?
No, Sumit is not here.
No, he's not there. He's not there.
Okay. Okay. Now I would like to also welcome the new supplier member, Poonam Plastic Industries. Mr. Girish Lakotia. He's the manufacturers and importer and exporter of the rotomoulding powder, foam powder, and custom molding products. We welcome you to our ROMA family. Mr. Lakotia is present?
No, he's not there.
Now I would like to introduce our next supplier member, Mr. Ravi, our friend Mr. Ravi Kadiwar, who has joined recently as a green. He is the managing director of Greenage Industries. I welcome him to our Roma family. As you know, that Greenage Industries is a pioneer in powder and especially compounds, supplying all major rotomoulding industry in India and overseas. Greenage have a modern making, powder making facilities for the butene, hexene, and other octane materials, and they have also got a testing facility in-house. Mr. Ravi Kadiwal is a thorough gentleman and true technocrat and passionate for rotomoulding. We once again welcome Mr. Ravi Kadiwal to our Roma family and anticipate your active participation for the coming years. We request all the non-members who have still not become the members. We request them that they should become member and avail a special membership package, which are the special scheme is going on where once you pay the money, you will be member till 2021. For that, you can contact our website.
Raviji is here. Raviji.
Yeah. Mr. Ravi.
Yes, Manoj.
Yeah, we welcome you. Can you give your self introduction to all our members? Raviji?
Sure, sir. Am I audible?
Yeah, sure. Yeah.
Thank you, Sethi, for the introduction of Greenage. And thank you, Mr. Ronny, for an informative presentation. It was a very nice presentation. And similar to what at Ultra Polymers we believe that quality is not our USP, but it's part of our culture at Greenage. Be it quality systems, we are Germany TUV certified ISO company. Be it quality machines, we have world-class high-tech compounding and polarizing systems, automized auto bagging lines, which is possibly the first one in India. Be it quality research and development, we have full-fledged lab setup, which has a rotomoulding machine with PIIT facility. We have ARM low temperature impact testing equipment. We have VSCR testing equipment. We have tensile impact, majorly all the tests which is required for rotomoulding applications. Be it quality grades, we have 7 ready stocked available grades, which is hexene, which has 2 hexenes and 1 octanes. We have special grades like marble effects, antimicrobial grades, and similar. We customize powders for automotive applications, for marine applications, for underground applications. I guess that's all. I look forward to amazing time at Roma and to align with its agenda of growth of Indian rotomoulding industry, which is also my vision, my mission, and my passion. Thank you, Roma, for this opportunity. Look forward to working with you guys. Thank you.
Thank you. Thank you, Raviji, for giving the good introduction to all the members. I think Mr. Chandu Shah is also present in webinar. I request Mr. Chandu Shah to give few words to our Roma members. Can you unmute Mr. Chandu Shah?
Okay, is it? Can you hear me?
Yeah, I saw. Yes, yes, yes.
Can you hear? Okay, wonderful. Mr. Shetty, thank you very much for inviting me. I think it was a delightful session. I also appreciate Ronnie's very enlightening presentation. There's very, very interesting, and a long way to go for many of us, I think, describe. And I wish you very good luck, and we will certainly be joining you, of course, with pleasure. Thank you.
Thank you, Sasa. Thanks for your service.
Can you hear me?
Yeah. Thanks a lot.
Have you heard me?
Yes. It's audible, yeah.
Thank you.
Thank you, Mr. Chandu Shah. As you know, we have updated our website, and now you can give your advertisement for the business promotion. So for details, you can contact Mr. Manoj and Mr. Vipul. It is a very interesting website, and very well accepted by all of the world, and a lot of people are visiting frequently to this website. So you can avail the opportunity to advertisement in this one. You can also avail the opportunity to sponsor our website and avail to promote your business. Now the different packages are available. You can avail these packages. And now I also thanks to our sponsor who always supports us from the beginning. Special thanks to M+, Matrix, Reliance Industry, Kaveri, Turbo, Hero Rotomolders, Aryan Plast, Puja Rotomech, Pius Rotomech, ML Industry, our bankers support by this thing, ICICI Bank and Swastik Rotomech. They are always supporting us. We request that in future also they will support us to upgrade the rotomoulding industry in India. Now I would like to give the details that our next webinar, that will be the 14th webinar, that will be take place on 22nd August 2020. The webinar subject is testing plastic in rotomoulding, and that is presenting by Mr. Manish Khandelwal, the PRC head of GAIL. It was a very interesting seminar. He is going to emphasize on all the testing of plastics in the rotomoulding industries. So I request you should save this date of 22nd August 2020 to participate to attend this webinar. We are continuously upgrading our webinars and seminar, and after that we are going to call Mr. Oliver from the Mouse. He's also going to give the presentation on the molds and things. So always we are bringing the international speaker to upgrade rotomoulding industry in India. Now I request Manoj Bhai to start this question and answer session for today's webinar. Over to Mr. Manoj Bhai.
Yeah, thank you, Shetty ji. And first of all, welcome to all members and non-members of Roma, and special welcome to our guest Ronny ji for a excellent speech. And I am starting my questions session. First of all, Yeah, first of hi, hello, Ronny. Hello, am I
Hello.
audible?
Yes.
Ronny, I'm audible.
Yep.
Yeah, first question is from industry. What's a resin suitable for underground application, and what's additive have to be added for better properties?
Yeah. Well, for underground products, we normally use densities around 940 and above, and MFR around 4. That is to make sure that you have a tough and stiff product. So when you say around 940, then someone call it linear low density, some call it medium density, and some call it high density. We in Rotomoulding, we are just in between. So I say around 940 with low MFR. You know, if you use higher MFRs, then or melt index, MFR and melt index is the same, and then it's if you use higher than 4, it's also more difficult to weld with a pipe. The normal pipe is has a MFR of 0.5, so much lower than we use in Rotomoulding. So yeah, when it comes to additives, the most important thing is to have a sufficient antioxidant package with long-term and short-term additives or antioxidants. Short-term is that normally the underground products are big and it has a long residence time in the oven. I've seen products that are in the oven for much more than an hour, and then you need to make sure that it's very well stabilized, and you need a long-term antioxidant also to support it for its lifetime. So, but I'm sure that all the material suppliers here knows how to stabilize it correctly. UV is less of importance, especially if you use black, because if you use the correct carbon black system, then the carbon black has a much better UV protection than any additives you can put into it. Yep.
Okay. Yeah, thanks. Next question is from Sarthak Mahaprasad. He is asking about how can we differentiate for P100 pipe and the P100 RC pipe?
Yeah, that is in Rotomoulding, you cannot use P100 or P125 or P80. What is because in pipes they have this fantastic shape of a cylinder, which makes them very easy to make this hoop stress test. We are doing in Germany to be allowed to make tanks and anything that is connected to a house in Germany. You have to, additionally to all the standards I've been through today, have a DIBT certificate, and then they make a rotomolded pipe and take hoop stress out of that. Very tough test to pass. So in theory we could use it, but in real world our products are not pipe, and it's not an easy design. That's one of the benefits of rotomoulding, that you can have any design you want in a way. So that is not suitable to make a P100 or P80 classification in rotomoulding. And it's not done yet in the world. I would like to see it, but it's not there. I would focus more on getting the standards implemented that are needed, and then you can have use the hoop stress to calculate, to give an advice on what is minimum wall thickness you need for your tanks. What is also very interesting work going on in Germany. They are really leading this one, and they are by getting all the material data, that they are also thinking about approving tanks by using final element analysis. So they are, when they have all the data done on in an accredited laboratory, then they put all this data into a computer with the design of the tank, and then the goal is to say yes or no based on this simulation.
Okay, thanks. Next question is from Prashant Trivedi, Mr. Prashant Trivedi, Sangir Pipes, and he is asking about PP pipes, PP copolymers, which can be used for sub-zero temperature. What are the limiting temperature on negative levels? I think you are.
You can have it, it depends on the material, of course, but you can have it down to -5 and -10 with a block copolymer, no problem. Normally, I will speak about Norway, because Norway I know most, when it's -10 outside, they really hesitate to dig in the ground because it might be frozen already. But if you have to replace a pipe that is broken, you have to do it although it's -10 or -5. But that is you cannot give let's say block copolymer -10. Okay, that is different from material to material. There are also different types of block copolymers. But if I would say it like this, that if you are making a pipe outside and it's minus and it should be PP, then you should use a block copolymer. That is how I would phrase it.
Thanks. Next question is our members, and even Roma is asking, can you arrange a copy of EM standard like 13598, 1256 for Indian for making Indian standards?
I cannot send you these standards. In Europe, they are you have to go on the web and pay money and download it, and you can do that from India as well. So all of these are easy accessible on the website, and I think that if you take those standards as a base for your standards and then you modify it, take out what is not needed in India and put in what other concerns you have, great base for standards. You should try to really put into all details which this standard is valid for. In Europe, it's very, let's say, vague defined, but you should put in sewage treatment systems. You should put in this is for septic tanks. You should put in this is for all kind of manholes, or yeah, you should make it more easy for the rotomolder to understand which standard he has to follow. That could be a mess in Europe sometimes.
In fact, in India, all the underground rotomoulding product manufacturers are integration with the pipes, so they are well aware about Indian standard. So we will arrange these copies from outside, and we will change in necessary requirements in Indian conditions. Yeah, thanks, yeah. And the next question is from Siddhant Chaurasia. I think Siddhant is here. Siddhant, are you here? Okay, yeah. Siddhant is not here. I'm asking a question, his question. Yeah. When various underground applications are being considered, can HDP be used there alone or in blend with LLDP?
Yeah. First of all, what is HDPE and what is LLDP? We have to agree upon that. the company I'm working with now and distributing material for, he says there's only two types. It's LLDP and HDPE. MDP doesn't exist, he says. So he says that everything from 940 and up is HDPE, and everything from 940 and down is LLDPE. So if you take that as let's say a reference, then you should use HDPE alone. How are you blend? If you make a blend, normally if you blend LLDP and HDPE, let's say pipe HDPE and a film LLDP, and you can get a kind of super linear, which is fantastic materials for rotomoulding if you have the correct molecular weight distribution. But for rotomoulding material, you should not blend it, dry blend it at least. You should never ever dry blend any materials. You should use them alone. So I would say for all the underground applications, big and small, it doesn't matter. Use around 940, let's say 938 to 945 ideal materials. Yeah, and then the next question, considering HDPE alone, which application in specific within? You can MFA density with if you have a material that is used in infrastructure. Now I'm on the last question on this page. You can produce let's say a 1 liter bottle and 50,000 liter, or if that exists, 30,000 liter water tank with this material. It doesn't matter if you have a 940 MFR 2 or if you have a 934 MFR 8. The 940 MFR 2 or 3, you can produce a 1 liter bottle, and you can produce a 30,000 liter tank. The MFR and density doesn't matter. What's mattering if you are producing small items is that you have the correct powder, that the powder distribution and the shape of the powder and so on, if that is good. If that is not good, you will struggle to make good products, especially on the technical smaller items. But if you have a good powder, no problems. You will have a longer cycle time, of course, to collapse the bubbles with a low MFR than with a high MFR. But you can make any product you want with a good material for underground applications. But the powder shape, powder dry flow, and the bulk density is very important.
So this is Siddhant here. Am I audible to you?
Yep.
Yeah, sir. So continuing on the same question, what kind of molecular weight distribution is preferred for this kind of applications, wherein say a broader MWD would be more preferable, or a narrower when you are considering 30,000 liter tanks? Specifically, I'm asking for underground tanks, wherein we are seeking certain applications like biodiesel tanks, which are made up to 30,000 liters as well.
Well, in rotomoulding, you need a narrow molecular weight distribution. If you have a very broad molecular weight distribution, as you have in pipes or blow molding and things like that, then to melt everything, also the very big long chains, the smaller one will degrade and burn before you make a product. So in rotomoulding, preference is to have as narrow as possible. weight possible, everything goes fast. You rotomoulding goes fast, so you save energy, you save cycle time, and so on. What I'm working with now is a kind of a smart company that is making narrow molecular weight distribution with a small shoulder, because the long chains that you have in pipe, they gives extra strength and durability to the material, and ideally we should have that in rotomoulding as well, but then it makes it very difficult to process. So this company I'm working with now, they have a very narrow molecular weight, and then they have a small shoulder of long molecules. That makes it that you need to process it a bit longer than traditional rotomoulding materials, but it makes it super tough. So I would say that you make it as narrow as possible, and then try to move it to the side that you get the longest chains as possible without sacrificing too much of the processability.
So for these applications wherein say underground 30,000 liter tanks are to be made, so what kind of MFI and density is preferred?
Please say that again. Could you repeat your question?
Yeah, am I audible?
Yes.
Yeah, so what I'm asking is for applications like having a 30,000 liter tank for underground application, something like a biodiesel or something similar. So
Yeah.
for these kind of application, what kind of a MFI and density is preferred when we are considering the narrow molecular weight distribution?
Yeah, the same MFR and density as for as I told you, 4 or lower and 940 and higher. But also what you have to consider with biodiesel is that a biodiesel is much more aggressive than standard diesel. So you need to have a stabilization system, an additive that makes the biodiesel not attack the polyethylene. So you need an antioxidant system that really protects the material from biodiesel. That is very, very, very important to consider.
Thank you, sir.
CTG?
Yeah.
I think
Yeah.
it's been done. Now you can tell Deshpande ji to give the vote of
Yeah.
thanks.
Yeah. Okay. So before the concluding thing, I would like to thank to Mr. LK Singh sir. With there is great effort, he could have bring Mr. Ronny for this webinar. So LK Singh sir, thanks for a lot. Would you like to say something for Mr. Ronny? LK Singh sir?
No.
Ronny is fantastic.
Yeah.
It's been a very good presentation, which I think the country needs very badly. We need to know a lot more, and I hope he will give us more education in future. And he's really enlightened us in the way that they are handling things. And I think this is going to change the future of India in underground tanks and water storage and water treatment and so on. And I think that whatever I say is too less, but Ronny's done a fantastic job. Thank you, Ronny.
Thank you very much, and it's been an honor to be invited to hold this seminar. And hopefully, when this Corona COVID-19 is passed or over, I will love to come and see you again face to face.
Thank you, Mr. Ronny and Mr. LK Singh. Now I request Mr. Deshpande ji from the Puja Rotomoulding to give the vote of thanks and conclude this webinar. Mr. Deshpande ji. Mr. Deshpande ji is there?
Deshpande ji,
Can you
आपका
connect?
unmute कीजिए ना. Hello, Deshpande ji? Yeah. Hello. Deshpande ji, can you hear us? I think so. There is a
Just
poor
connect
connection. Hey,
Yeah,
he
yeah,
is
yeah.
online. I can see him. He is online only, but we can't just hear his voice.
Just call him to unmute his system. This one is okay.
No, we can't hear his voice actually. Deshpande ji, we can't hear you. I think so. There is a sir. एक काम कीजिए आप yeah. Tell him to switch off his video and then he can tell or something. I think so. There is a network problem. It's a poor network actually. Sethi ji?
जी आप कंटिन्यू कर दीजिए.
Yeah. Shrikant ji? Hello.
Shrikant?
Bhushan ji, can you call him please? Sethi ji?
Yeah, just Netik is talking to him. He's just connecting this one.
Okay.
Meanwhile, I request Mukesh Bhai is there. I think he's left. We have got our lot of this time we have got a lot of overseas clients from the Africa. We welcome our overseas participant also and request them always participate and take a initiative in the ROMA activities and also join the ROMA activities. He's joining. I think Mr. Gary is also there. Say a few words to Mr. Ronny on this presentation. Mr. Gary, by the time Mr. Deshpande is joining.
Okay, hi guys, thanks. Yeah, Ronny, good presentation. Something different for the guys to all think about, as Lal said, and something very important for India. A lot of people in India are talking about going below ground and ground tanks. So I think this is very appropriate for the time. Well done, Ronny. Good one.
Thanks, Gary. Appreciate it.
Okay. Shrikant, can we join now? I think meanwhile we can join Mr. Venkatesh from Prince Industries also join with us.
Sethi ji.
Mr. Venkatesh, can you hear us? Welcome to our ROMA team. Mr. Venkatesh, can you hear us?
Sir, he is not there, I think so. He's there, but he's not listening.
He's not.
Hello?
Can you?
Manoj ji?
Yeah, Mr. Venkatesh.
Yeah. Hello. Hello, good afternoon.
Yeah, continue, Mr. Venkatesh. Join the
Yeah, very good afternoon, sir. I'm Venkatesh from Prince Pipe and Fittings. On behalf of Prince, I'm here. I was really happy to see this presentation. It's a wonderful information we got. and especially we are in expansion mode. So got very good products like new products like inspection chambers, and not only inspection chamber, underground drainage, and also for water treatments and all. We got a lot of input from today's presentation, and we love and we would like to continue keep in touch with Mr. Ronny and also with Roma for bringing new more products in for the as well as for India in way of infrastructures. Thanks a lot. Thanks a lot, Mr. Shetty, for giving me an invitation even as a not member, and definitely will be a member shortly. And thanks a lot for this giving opportunity to speak on. Thanks a lot. Thanks a lot.
Yeah, it's a pleasure. And if you need more information, you can contact me directly by email or phone.
हेलो सर, आवाज आ रही है? हेलो,
या आ रहा है या
ओके, आवाज आ रहा है? मनोज, आवाज आ रही है मेरी?
या यू आर ऑडिबल
Guys, audible.
हेलो,
हाँ बोलिए ना।
राजीव जी, आवाज आ रही है? ओके ओके. Honorable ROMA members and non-members, respected speakers and sponsors, and my dear ROMA LGC board members, I, Srikant Pandey, Head of Operation Pooja Rotomoulding Jalna. Pooja Rotomoulding is a pioneer company into business of high-end rotomoulding molds under the guidance of Mr. Ratnakar and Bhagwan Padale. I feel honored and privileged having an opportunity to offer vote of thanks of this memorable occasion. First of all, I would like to thank all the seniors and superiors for showing trust in ROMA. I am extremely elated to announce the successful closure of today's 13th webinar. We got overwhelming response and love across the roto industry, and we sincerely thanks all ROMA members for attending the series of webinars and getting knowledge, enhancement, and learning. Mr. Ronny Ervik is very well established name in the rotomoulding sector and have a business almost major countries across the globe. Very soon, we will be meet again our 14th webinar on 22nd August 2020. Thanks once again. Thanks, Mr. Ronny and all the GC members. Thank you very much.
Thank you, sir.
Thank you, Deshpande ji.
Thank you, Deshpande ji.
Thank you.
Thank you all for the attending.
Thank you.
Thank you, sir.
See you.
Thank you.
Thank you.
Thank you, Ronny. Thank you, Gary.
Yeah.
Have a good day.
Thank you, Ronny.
Thank you, Chandu sir. Thank you.
Thanks,
Good day.
everybody.
Bye-bye.
Bye. See you next week. Bye. Thanks.
Thanks. Yeah. Yeah.
Have a nice day, sir.
Thank you.